Hi everyone, and welcome back to the face recognition tutorial series on viewtutorials.bravesites.com. This is Mavish and you're following level 4C part 3, which is to collect images for your training set, that is the how-tos. So let's have a look at what are the learning objectives of this tutorial. The major aim will be to collect face images that will fill your faces database, and such that you also learn how to achieve maximum possible correct recognition results by carefully making the training set. Because as we know that the face recognition results majorly depend on how well the training set is made, and the training set contains all your objects, or in this case the faces that you want to recognize later on. So follow the guidelines or tips in this tutorial to collect your faces for your training set. And this tutorial is basically aimed to answer some of your fundamental questions or doubts while creating a training set about how to create it or what to be careful about and what not to be. So moving on. Now, face recognition algorithms results depend completely on the face images collected for creating the training set. Same is the case for PC eigen faces, which especially is sensitive to following properties of face images in the training set. For example, the lighting on the face, that is the direction or intensity, the lights coming from the left side or the right side, or from top or from bottom. And then there comes face expressions. For example, if the person whose image is being stored in the faces database, the expression at that time was sad, angry, or was it winking, was it normal, wearing glasses, was the person wearing some makeup or not? And then the position of the face. For example, the rotation and the tilt of the face, is it facing left, facing right, and the image quality. That is, was it taken from an HD camera or from a normal web camera? Because quality differs in both of the images, and even the resolution, that is the size of the image, differs. Now, this is a non-exhaustive list of the important properties of the face images, but this is just to give you an idea that there are so many variations in your environment that actually affect the result of your face recognition. So to ensure that your recognition results are good, you better take care of all these variations in the environment. So moving on to our first question. Now, the very important question should begin with that: do I need to collect faces for making the training set, the faces database? Can I just collect some random images? For example, you're just trying to make a face recognition system, and you just want to try out how it works. So the answer is that it totally depends on your system. For example, if you're making a system that will be implemented in a real-time environment and will recognize faces of certain people, say the employees in an organization or students in a class, then you have to make a training set with images of those certain people that you will recognize later. So what you do is you go to those people and you ask them to sit in front of your camera, and then you take their pictures, and then the rest of the procedure goes on. Otherwise, the second option is if your system is just for proof of concept or self-study, or not to be implemented in real time, for example the one I'm implementing in these tutorials, then you can simply get a faces database available online to implement your system and check out the results. For example, even if you're considering some research on multiple databases available online. So I will be using the Yale Faces database. Now, Yale Faces database, you can get it online from their website directly. I will not be distributing this database because it is within their policy that I cannot distribute it without their permission, and right now I have not contacted them. So you go to their website. Now, this is the website of Yale Face database. As you can see, the link over here, I will give this link in the video and in the tutorial, so you can go over there, go visit it. And what you do over here is you just click this download button and your download will start. It is a zipped file with you can see what's included in the file. It says the Yale Faces database, size this, contains 165 grayscale images in GIF format of 15 individuals. There are 11 images per subject, one per different facial expression or configuration. That is center light, happy, left, right, and this. So it contains the images as mentioned over here. And I think this Yale Face database is one of the most perfectly working example of face recognition. The maximum possible results achieved with PC Icon Face, as far as I've seen, were with this database. Now, once you have downloaded the Yale Faces .zip file folder, you can see that these are the contents of this zip file. So you just open it up and you can see that these are the various faces. Now it so happens that, I don't know, their extensions are missing. Maybe, for example, the .gif part over here, it's .set, only the expressions part is left, but the extensions are not written. So just take a look at this. Now this is the images will look something like this for every person in this database. Now I already converted some of them to the .bmp extension. I just renamed it. You click it and then you rename it to, you just add the extension. Yes, and as you can see, now this image is viewable. The image was not corrupt, it was working perfectly, but it was just not viewable in a Windows folder, as you can see over here. So you just needed to add an extension that Windows folder can let you then view it. And when I have renamed all of them, when I have added extensions to all of them, they looked something like this. Now these are exactly as written on their website, 15 people with 11 face expressions each. And when you download them and when you view them, you can have a detailed look at what they look like and which expressions are. So that was for the option 2, but moving back to option 1, where you are implementing some system for some specific organization or people. For example, I did my final year project for student attendance marking. So I had to ask all the students of the class that I was working on the project for, that they sit in front of my camera, and then I made an application by myself which took their images from the web camera, the camera application that I already uploaded and discussed with you guys in previous tutorials. So that was the basic of my application. And then I had a button which saved the face to the a folder I called collected faces. So you could do that, or if you have any better idea, you could go with that. So the point is I just wanted to tell you that how it works. You actually have to go to the place that your system is going to be installed, where your system is going to be installed, and you're going to have to ask the exact subjects that you want to recognize later on, that they sit in front of your camera, and then take their images and collect them. Okay, question number question number 1, yes. Should I take one face per snapshot image, or there can be multiple faces in one image? Well, again, it depends on your system's need. If you haven't understood the question, I'll repeat it once again. What you're asking is that should there be only one person in an image that you're going to input to your system, or could there be, for example, 7 persons in the same image standing, for example, a group photo, or should that be the input of your system? And your system can recognize all of the faces in the same image, or are you going to have to split those faces and then input it to the system, and then the system is going to recognize? So the answer is that it depends on your system's need. Both are possible. If you're taking student attendance in a class at runtime, you may want to take a single image with everybody in it, that is a group photo. For example, as I did, if you haven't seen the demo video on YouTube that I uploaded, or on my website, then please have a look at it, because I did this method. I had a group photo of the whole class, and then I asked my system to recognize each face and then mark each face on the same image. this is the example from my final year project. So the students were sitting in front of my system, and I took a collective image, a group image of the whole class, and then my system recognized and marked all their names and faces right on the image. Or your system might want each person to form a queue or a line at one time in front of your system and have their individual image taken to be recognized. For example, an employee attendance system, each employee enters the gate, and when he enters the gate, the system takes the employee faces towards the camera, and the system takes this picture of that one person and then inputs it to the recognition module, and then everything goes on. For example, this is the individual image. By the way, these two images are from the YieldFace database. Okay, now second question. How many faces must I collect per person? Well, just make sure you collect a sample of each possible condition that a face can look like when coming for recognition, that is at runtime. So what you do is you cover all various face expressions and light conditions that may be possible at the time when your system is finally going to recognize the face in real time. For example, the YieldFace database that I already showed you an example of how many faces they collected for each person and which expressions they covered. So I'll just go through it once again. As you can see that each person has about 9 and 10. This person has 10 images, 10 samples per person. They initially said 11, but anyhow, there's 10. So what's important is that you can see the various lightings and the various expressions of the same person. I'll make it big. Okay. As you can see, the happy expression, the normal, the one with the glasses, one with the right light from the right side, then the sad expression, the sleepy, the non-glasses, and then there's a surprised version and a wink version. So this is a great example of showing that which variations in the face of the same person you should capture in your training set, so that your system can recognize your person better. When this person comes in front of the camera at recognition time, the system will have a better chance of recognizing him because it already has a lot of different variations of his face. And you don't do this for one person, you do it for everybody that you're storing in your training set. So as you can see, everybody has various expressions and various lighting conditions. And you will see when I run the system that doing this, that is capturing every variation, will have excellent results on the recognition. Okay. Now guidelines on we continue with the guidelines. Question number 3. How many faces should the training set contain? That is, how many persons should I make one for how many persons should I make one training set? Well, it depends on how many faces per person you have. That is, how many samples per object in your training set, keeping the fact in mind that the faces in the database must neither be too similar nor too different, neither too many nor too little. For example, you could follow the ratio example, and this is no hard and fast rule, and I just came up with it from my experience. For example, you have four faces, and then you get total, and you have total 5 persons, then you get total 20 faces in your training set. Similarly, if you have 8 faces per person and you have total 15 person, so I hope this is the right sum. I don't know. Well, yeah, it is. I just checked with the calculator. I'm sorry, I'm a bit weak with the mathematics. Okay. Anyhow. Now, question number 4. Can I use different cameras to collect face images and to recognize a face? I discussed about this before, and the simple answer is I suggest you do not do that. You see, different camera equals different image quality, which means difference in face images of the same person, which means bad recognition results. Instead, collect images for your training set with the same camera that you're using in your face recognition system. In fact, use the same application you are developing, your face recognition system, to collect these images in the same place that is your system will be deployed at runtime. This is what I did, and it had better results. Okay, now question number 5. Where should I collect my subject's face images? The school, the office, my home, garden, or anywhere? Again, some of the answers or questions you will find them repeating, but I think it's only to emphasize their importance, the importance of the answers to them. So, different location means different light conditions, which means difference in face images of the same person, which naturally equals to bad recognition results, and that is not what you want, right? So, you should take your subjects snaps in the exact place where their faces will be recognized at runtime. For example, you want to take attendance of students, then you should collect your images in the same fashion that you're actually going to recognize their images. So you have them seated in front of your camera exactly the way that you want them to be seated when your system is finally going to recognize them. Because this ensures maximum possible similar surrounding conditions for the training set images and test images. The training set images is the one that you're filling the face database with, and the test image will be the one that will not be in the training set. And this will be the image that will be taken at the runtime for recognition. Always remember that an image that is in the test set is never in the training set, or it will return you the exact same image, so that's a no-no. Anyhow, therefore this method will give better recognition results. So for that, I suggest you use the same application you're developing, your face recognition system, to collect training set images too. I did, and it did give better results, and in my implementation I hopefully will cover this part. Okay, moving on to our second last question. What should be the resolution and size of the image I collect? How big can the face be? Any resolution of the image is okay as long as the image size is not too big, because the bigger the image, the more processing time it takes, and time is really precious when you're going for real-time critical systems. So 100 by 100 or up to 200 by 200 is a good enough size, I think. I used 100 by 100, and the image is of good quality. Make sure that the image is of good quality such that the face is clearly and easily detectable by your system. If the quality is not good, for example, it's a low resolution image, it will be highly pixelated, and I don't think it will add to that much of information for your recognition. But an image with a good resolution definitely will. But remember these necessary precautions in creating the training set. All and each face image in the training set, as well as the test face, must be of the same size, otherwise there will be error. If you read or listened to my tutorials on PCA, then you know that the test and the training set image must be of equal size, otherwise the algorithm is not going to work. And if you apply a pre-processing technique to a face image that goes in the training set, you must also apply it to the test face image when you recognize the face. Otherwise, there will be bad recognition results, because there will be simply, for example, you brighten the training set images, but you did not brighten the test image. So what will that do? The pixel intensity values will differ, and your recognition algorithm will presume that the person is totally a different person. So there will be two same persons, but the system is going to reject him. So you don't want that. And on to the last question. What pre-processing methods can I apply to face images to enhance recognition results? Some are pretty popular and useful. For example, remove background from the face image, or equalize the histogram. I found it to be not always the best solution to do this. I mean, you could if your image requires it. The other could be aligning faces. For example, there's a tilt in the face. The person is, tilting his face to the right or the left. You could straighten it. But remember, once again, if you apply any pre-processing technique to a face image that goes to a training set, then apply it to the test set image as well. Otherwise, bad results. So that was it for how to fill your training set and the precautionary measures that you need to take care of in order to achieve the best possible results of face recognition. And I hope you liked the tutorial. See you in the next episode.